Okay, so this is the projectile problem from our review. This is number 19. We talked about this briefly in class. A couple things that I want to highlight, though, is in part A, what we want to do is we want to find how far from the kicker will the ball land. So I'm going to draw a real quick picture with part A. I'll draw a quick picture for part B and solve these real quick. A couple pieces, though. We need to know what each one of these equations is used for. So our x is for our horizontal distance, and our y is for our vertical distance. Okay, so for part A, I want to know how far it's going to land. So we got our little guy here kicking the ball, and the ball lands. So I know the ball lands when height is equal to 0. Well, that's a vertical distance, so what I'm going to do is I'm going to use the givens that are given to me at the beginning of the problem. And so for part A, let me erase that real quick. So for part A, what I'm going to do is I'm going to plug in the information that I need. I need my y equation, and I know that the velocity is 30 feet per second. We're taking sine of 60 degrees. And if you remember correctly, I made a slight correction, and we called that 4t instead of 22t. Okay, so let me just make this 4. Okay, and so now I am going to go ahead and set this equal to 0, because I know my height is 0. And solve. Sine of 60 is root 3 over 2. Okay? Oops. And I'm going to go ahead and simplify this. I'm going to pull out my calculator, and I'm going to go ahead and solve. But basically what I have here is I'm going to 0 is equal to 15 root 3 times t, all minus 4t squared. I can factor out a t, so I'm going to flip-flop this. I'm going to put 0 on the other side. I can pull out a t, and I have 15 root 3 minus 4t is equal to 0. Now I'm going to go ahead. I have one of the factors where t is equal to 0. We know that that's where the ball is starting from. And then I have this other one. And I'm going to go ahead and solve for t, and t is going to be approximately 6.5 seconds. Well, I know that it takes 6.5 seconds to travel this distance. And I used the y equation to find that. And now I know that this guy right here, this x equation, gives me a horizontal distance based on time. So I'm going to go ahead and let me move the screen down. So this is still part A. I know that x is equal to my initial velocity, which is 30, times cosine of 60 degrees times t. So x is equal 15t, and I know that t is 6.5, not 8.5. Which is going to give me approximately 97.5 feet. And that is how long the ball is kicked. I'll come back and I'll do another video for part B.